I'm Anil Kumar sharing with you a test question on higher order derivatives. We are given x to the power of m times y to the power of n equals to x plus y to the power of m plus n. Prove that dy by dx is y over x and d2y over dx squared is 0. Whenever we are given exponential functions like this, we prefer to take logarithms on both sides and then find the derivatives. You can actually pause the video now, solve the question, and then look into my solutions. So what we are given here is x to the power of m times y to the power of n equals to x plus y to the power of m plus n. Now if I take natural log on both sides, then we get natural log of product of left side equals to natural log of right side, correct? So you can write this as product, correct? You can write ln x to the power of m plus ln y to the power of n, which is equals to m plus n to ln x plus y, correct? Now we'll differentiate both sides with respect to x at this stage. So what I'm trying to say here is that we'll do dx of the left side, which is ln x to the power of m plus ln y to the power of n, and ddx of m plus n times ln x plus y, correct? Now derivative of ln x is 1 over x, right? Well, we could write this as m times ln x, correct? Where m and n are constants, correct? So let me rearrange this. One more step will go, and then we'll do derivative on the right side. I can write this as m times ln x plus n times ln y. I should have done that before anyway. And we get here ddx of m plus n times ln x plus y. So let's move on to the right side. Find the derivatives. So that gives me m is a constant. So we get m over, this is ln x, right here, m over x, right, plus n times 1 over y times dy dx equals to, on this side we have, that is a constant, m plus n over x plus y times ddx of x plus y, correct? Okay. Now let's rearrange. We'll just multiply this and then do it. Let me squeeze in. Plus n over y dy dx equals to m plus n over x plus y, and the derivative of this function is 1 plus dy dx. So we can arrange dy dx now. So we have one factor minus ny, and we'll bring this to the left side. So we have m over x minus, so when you multiply this by 1 and bring it on the left side, it gets minus of all this, which is m plus n over x plus y. And here we are taking dy dx common. So we get all this factor, which is m plus n over x plus y. And we'll bring in this on the right side, so which is minus n over y. So I kind of saved one step here. I'd like you to go through this once again and check for yourself how we get this result. So let's take common denominators. So we get m times x plus y minus x times m plus n over x times x plus y on the left side. Here we have dy dx of x plus y times y. Y gets multiplied with m plus n minus n times x plus y, correct? Let me move this page a bit. I hope you can see it. Okay, so it's a matter of combining them and simplifying. So mx and mx cancel out. Is that okay? What we get here is my minus xn, correct? So we get on the left side my minus x times n. Denominator is x times x plus y. On the right side, we get, so n times y and n times y gets cancelled. So this term gets cancelled, right? So what we get is ym minus nx over x plus y times y. Perfect. On this side, m times y, the x terms got cancelled with m. Do you see that? Okay. Now what is dy dx? We'll just cross multiply. Perfect. Now, if you cross multiply, we get dy dx as equal to y times x plus y over this term, which is ym minus nx times, here we already have ym minus nx. I just rearranged them, commutative law, and the denominator we have x times x plus y. As you can clearly see, these terms cancel away and x plus y also cancels away. So we get dy dx as equal to y over x. Perfect. So we have proven the first part of it, right? So now we know that dy dx is indeed equal to y over x. So let's move on to the next page and find the second derivative of the function. Perfect. So now we'll do second derivative. We know dy dx is equal to y over x. So d2y dx will be d dx of y over x. So we can apply the quotient rule, which will give us x squared dy dx derivative times x minus y times derivative of x, which is 1. So that is second derivative. Now we know dy dx is y over x, and therefore we could write this as y over x times x minus y over x squared. Perfect. Now here you can cancel x and x, and what you get really is y minus y over x squared, which is indeed 0. So we have shown that the second derivative is 0. Perfect. So that is how we can do this question. I hope you find it simple and interesting. Feel free to write your comments, share your views, and if you like and subscribe, that'll be good for me. Thank you and all the best.